Okay, moving on to our next lesson. So we just got done with 7.1 and 7.2, and now we are moving into 7.3, which is logarithms and logarithmic functions. We're going to probably spend a couple of lessons on 7.3 because logarithms are something that we are being introduced to for the first time here. So our goal for today is to be able to convert between exponential functions and logarithmic functions, and then use that to help us evaluate an expression. So let's go into logarithms, converting between logarithmic and exponential functions. So this right here is what a logarithmic function looks like. Log base b of x equals y. So when it has that little subscript right there, so you have log and then it's a small number b, that is called the base of the logarithmic function. And we can convert between logarithmic and exponential functions. So as you can see here, it says log base b of x equals y. If and only if b to the y equals x. So you're going to take whatever number that base is and raise it to whatever y is, and then set that equal to x. So for example here, we've got if log base 3 of 27 equals y, then we can rewrite it as an exponential equation as 3 to the y equals 27. So notice how my base of 3 here became my base of the exponential function, okay? My y then was put as the power here for my exponential function, and then lastly we're taking that 27, and that is what it is going to be set equal to. So we're going to start off with practicing converting from logarithmic to exponential, and then vice versa, and then we're going to go into how we can use that to help us solve. So let's start off here with writing each equation in exponential form. Okay, if it helps, write it at the top. We've got log base b of x equals y, and then that converts to b to the y equals x. Highly recommend doing this for any of your problems. So for example, on your assignment, write that right away so that you can take a look at it and it'll help you to convert. Okay, so we've got log base b of x equals y. Log base 2 of 16 equals 4, and we want to convert this into exponential form. So the first thing we got to identify is our b. So log base b, in this case 2 is our b. So I'm going to start off by writing the 2. Now that's being raised to my y, so after the equal sign here I've got a 4, so it's going to be raised to the 4th power. And then equals x, so log base 2 of 16. 16 is my x, so we're going to set that equal to 16. And it should work, right? We're familiar with exponential equations, so what is 2 to the 4th? Well, 2 to the 4th is 16. So go ahead and pause this video and give b a try. So convert log base 3 of 9 equals 2 into exponential form. All right, so when we convert this, we've got b to the y, so 3 squared equals 9. Okay, moving on here, we've got log base 5 of 120 or 1 over 25 equals -2. So same thing here, start off with the base of the log. So log base 5, and then raise that to whatever is after the equal sign. So -2 equals 1 over 25. So our x value. And again, we can double check it, right? 5 to the -2. We rewrite that, it would be 1 over 5 squared, and 5 squared is 25. So again, now on problem D, go ahead and pause the video and give this one a try, converting from logarithmic function to exponential function. All right, when we rewrite this one, it would be the base of my logarithmic function, so 1/2, raised to my y, so -1, equals my x value. Okay, let's move on to the next example. Now it says write each equation in logarithmic form. So we are working backwards. Now we know it's log base b of x equals y. And again, start off by writing that at the top. So we've got log base b of x equals y. And then in exponential form, that is b to the y equals x. So now all we have to do is identify our b, y, and x and then plug it in. So we've got log base b. So here in this case, my b is going to be the 5. So base b, and you're going to write it as a subscript. So it's not log of 5. It's kind of a smaller on the bottom right of that log. Okay, log base b of x. So what is my x part here? So the x in this case is 125. And then that equals y. So my y here is 3. And again, notice how actually writing this down can really help us to convert back and forth. Okay, so go ahead and do the next one on your own again. Okay, when we rewrite it, we've got log base b, so in this case, log of 27 of x. Well, x, what is our equation set equal to? It's set equal to 3 equals y, so what it is being raised to, which is 1/3. Okay, next we're going to talk about special cases. So we're going to use this converting back and forth to help us to solve, right? Solve for our variable. There's two special cases. So the first one is logarithm of 1. So notice how it's log base b of 1 equals 0. Well, think about it. If I were to convert that, so b to the y equals x, it would be b to the 0 power equals 1. Well, what is anything to the 0 power? It's 1. And we're again going to go over some examples of problems where this is the case. Now, logarithm of base b. When I have logarithm of base b, when we convert that, so we get b to the 1 equals b. Well, it's the same thing. Anytime that I raise anything to the first power, it is going to get that value. So it's just going to be b. Okay, so moving on to example 3, we want to evaluate the logarithmic expression. So here the first one is log base 3 of 243. We want to evaluate that. Okay, so how we're going to do is your first step is always going to be setting it equal to y. Okay, and again at the top, let's go ahead and write down log base b of x equals y. And then converting that, we get b to the y equals x. Okay, so our goal is to change it from logarithmic function to an exponential function because we are familiar with solving exponential functions. Okay, so let's convert this. So log base 3 of 243 equals y is going to become 3 to the y equals 243. All right, now from here, this should look familiar to you. All we're doing is now solving for what y is. Remember, I can't set the exponents equal to one another until they have that same base. So here we've got 3 and 243. So I want to change either one of them or both of them so that they have that same base. And in this case, I can actually change 243 so that it has a base of 3. 3 to the 5th power is 243. So I'm going to rewrite 243 as 3 to the 5th power. Okay, now that they have that same base, I can just set their exponents equal to one another. So y equals 5. Now, I don't have to do anything else because it's not an equation. So this is going to be my final answer. Okay, moving on to B, it says log of 1,000. So this is a special case where, as you can see, there is no base. Anytime that they don't have a base, it doesn't explicitly say what it is, you can automatically assume that that base is going to be 10. So if it helps, rewrite it as such. So we could say that it's log base 10 of 1,000. And remember, now we want to set it equal to y. Okay, now we're going to rewrite it as exponential form. So it becomes 10 to the y equals 1,000. Now, same thing. Can I rewrite one or both of those so that they have the same base? And in this case, I can rewrite 1,000 so that it has a base of 10. So 10 cubed equals 1,000. So I'm going to rewrite that. And now that they have that same base, all we have to do is set our exponents equal to one another. So we get the final answer of y equals 3. Okay, so go ahead and pause this video and then solve this equation. And then when you're done, press play so that you can see the answer. Okay, so here is your final answer. We get y equals 3. Okay, so again, you can pause it and take a look at the steps to see if you did the step correctly. All right, last two problems that we are going to go over. These two are examples of those special cases. So log base 4 of 1. First thing we're going to do is set this equal to y. And then after that, just like the last couple of problems, we are going to change it. So it becomes 4 to the y equals 1. Now, in this case, you might think, well, it's kind of hard to think about how would I change 4 or 1, but this is one of those special cases, right? 4 to what power equals 1? So if we go back to that special case here, this is a logarithm of 1. Log base b of 1 equals 0 because anything raised to the 0 power is 1. So as you can see here, when it has that 1 as its x value, you can automatically say that y equals 0 because it is one of our special cases. 4 to the 0 equals 1. Okay, for e, log base 2 of 2, we're going to start off by setting that equal to y. And then we are going to switch it into exponential form. So we get y, or 2 to the y equals 2. Well, again, it's one of our special cases. Log base b of b, so they are the same. So notice how they're both 2. The base and the x value is 2. And in this case, we can say when they are the same, it equals 1 because b to the 1 equals b. So y here equals 1 because 2 to the first power equals 2. So these are definitely some things that you want to make sure that you're looking out for, okay? Because this can help you save some time and some frustration by trying to figure it out.